let's begin.
So finish copying these down. We're definitely not going to get through all of them in the remainder of class, but whatever we don't get to, of course, try it on your own before tomorrow's class, because that will help a lot more with the retention and the learning if you actually go through it before I actually just give you the answer. That being said, as I mentioned last week, there are quite a bunch of these where I need to tell you something extra in order for you to be able to do them. I mean, with what I've told you so far, the ones you can currently handle, problems 4, problem 6, problem 7, problem 8, problem 12, problem 13. Yeah, I mean, in theory you could handle 11, 17, and 17 as well, but you wouldn't want to actually do it based on what I've told you so far. It's actually going to be very computationally intensive, and there are easier ways around it. But to get through the rest of them, there is something else you should also be able to do problem 14. For the rest of them, there's something else, or a couple more things that I need to tell you about. So, you will notice in situations like the first one, problem 1, we have x cubed times e to the x. This is a multiplication of functions. Okay. So I have two functions being multiplied together. Okay. So now you might wonder, how would I find the derivative of something like that? Okay. So the question is, if I wanted to take the derivative of two functions being multiplied, what is that equal to? And the typical student who hasn't taken Calc 1 before, it would make a lot of sense to them to say, well, I can just take the derivative of the first one and multiply by the derivative of the second one, right? And that would be wrong. That's actually not how it works. Derivatives aren't as nice as limits are. They don't distribute across products. That's actually wrong. So I need a brighter reading. And it's not actually that hard to see that that would be wrong, because that's just what about this? You get the idea. Okay, that's wrong, right? So, example. Let's say you wanted to differentiate x times x. And you decided, oh, I'm just going to differentiate x, which I know how the derivative of that is 1, and then I'm going to differentiate this x, and that is also 1, so the answer must be 1, right? But we know this is wrong, right? Because that's just x squared, and we actually know what the correct answer is for the derivative of x squared. The answer should be 2x. So it's clear, if you just have a multiplication and you decide to take the derivative of each piece, you're not going to get the correct answer, right? We know that this should be the correct answer. We actually derived this using the limit definition. So, dealing with a product is not just taking each derivative and multiplying them together. There's a whole process that one has to go through, and it's called the product rule. As its name suggests, this is how we differentiate products. So this was one of the bonus points on the quiz today. So basically the product rule says, if I want to differentiate two functions being multiplied by each other, sometimes we use u and v, f and g is okay, but if I take the derivative of f times g, what does that equal to? Did anyone actually? Yeah?
U times v prime v plus v.
Oh, well, so you're using the u and v. So in this version, what you're saying is you would take the derivative of the f, you would leave the g, and then? Plus
prime of g times f of x.
and that will be the font. This is called the product rule. this is actually how you take it. Another way to write this down, if I ask you to regurgitate the product rule, you don't have to write the of x, it's okay to write f prime g plus f g prime. So you want to think of it that way. So that is how we actually find the derivative of a product. And if you're interested in the y, not interested. Okay. If you're interested in the y, so let's say your y was f of x times g of x. How would you actually find y prime? Well, you find as the limit as h approaches 0 of f of x plus h, g of x plus h, minus f of x times g of x. You would divide that by h. You would then, and here's, there comes a little trick in here, where you would add and subtract a convenient thing. So you're not changing the value, but it's a little bit more convenient. You would subtract f of x times g of x plus h, and you would add f of x times g of x plus h in the middle. And this is minus f of x times g of x all over h. Then you would end up with, notice in the first situation, you can factor out a g of x plus h. And you'd be left with f of x plus h minus f of x. In the second case, you'd be able to factor out a common f of x. You'd be left with g of x plus h minus g of x. Now, of course, if this is all over h, you could actually split these fractions up. Now, what you'd realize is, at this point, the f of x plus h minus f of x all over h, with the limit as h is approaching 0, you know that to be f prime of x by the definition. Now, of course, as h is approaching 0, this guy just becomes your g of x. So you end up with f prime times g. Then there's going to be the plus sign here. This here, g of x plus h minus g of x all over h as h is going to 0, that you know is the definition of g prime of x. And of course f of x is just the limit of that is going to be f of x. So you end up with this rule. So it's something we had to actually derive. It's not so obvious as the derivative of a product, which is the product of the derivatives. That's not true. So derivatives don't behave nicely with products. You have this whole rule that you have to go through. It's called a product rule. Now, the derivative of a division is also not obvious. So a lot of people would, who again don't have experience with Calc 1, they're like, oh, if I just divide them, just take the top and the bottom. Doesn't work, unfortunately. So that, but we can also derive that. If I look at, say, the derivative of f of x over g of x, I don't have to go through the limit definition because I actually know enough to actually solve this based on the product rule and something I told you last time, the chain rule. So the derivative, I can rewrite this as f of x times g of x raised to the minus 1 power. Then applying the product rule, I'm going to differentiate the f, leave the g to the minus 1, plus I'm going to leave the f, and I'm going to differentiate the g to the minus 1. Now, how would I differentiate the g to the minus 1? Well, what you would notice is the g is an inside function. So I would need the chain rule here. So I'm going to differentiate the outer function, meaning I bring the power down, subtract 1 from the power, and then multiply by the derivative of the inside function. This is the chain rule. So here, use the chain rule. Which again, you should know how that was written. That was also on the quiz. The derivative of f of g of x is f prime of g of x times g prime of x. So you differentiate the outer function, multiply by the derivative of the inside. At the end of the day, you now end up with something that looks like this. You have f prime over g minus fg prime over g squared. And basically what you do is to create a common denominator, you multiply by g over g, and so we end up with f prime g minus fg prime all over g squared. And that is how you would differentiate a division. And this is called the quotient rule, because the result of a division is a quotient, and math people just name things by what they are. This leads to, it's called the quotient rule. So this was another bonus problem, just to state the quotient rule. And it basically says the derivative of one function divided by another function is going to be the derivative of the top times the bottom minus the top times the derivative of the bottom over bottom squared. That is called the quotient rule. So now, with those two rules, we are able to now do all 19 problems. In addition to the rules I told you last time. So last time I told you, important rules at a glance. And again, every time I give you formula, you really want to copy them down in one spot so you have all the rules together. It will help you in your studying and retention. So I told you about several things. One of them was the power rule. What does the power rule say?
N times x.
So remember, all the rules are equations. So there's a left side and a right side. What is the left side?
The derivative
The derivative of
x
To the
to
end.
the
the n is
n times x.
n x to the n minus 1. So this was the power rule. I also told you about how to differentiate e to some power. How do you do that?
To the
Huh?
e to the u.
No.
U
Yeah.
prime times e to the u.
U prime e to the u. Differentiate the power, multiply by the original function. What about the derivative of the natural log of something?
E prime over u.
U prime over u. We also spoke about the chain rule, which I just wrote down there. So this says the derivative of f of g, once you have an inside function plugged into someone, differentiate the outside function, leave the inside alone, then multiply the result by the derivative of the inside function. Now, I talk about something called the product rule. Of course, you use this to differentiate products. It says the derivative of f times g is f prime g plus f g prime. Now, the order in which you do the derivatives here won't matter because addition is commutative. Whichever one you do first doesn't matter. But the order in the quotient rule actually does matter because one takes a negative sign. So the quotient rule says the derivative of f over g is f prime g minus fg prime over g squared. And you do not want to mess with the order here. So you always take the derivative of the top, multiply by the bottom, minus the top times the derivative of the bottom. So these are the basic rules at a glance. Of course, besides these, you guys need to know about the properties. Derivatives distribute across sums. You can factor constants out, but they do not distribute across products. You have to go through this whole rule. They don't distribute across divisions. You have to go through this whole rule. that being said, let's get through a couple of these. And then in tomorrow's class, we'll just like rapid fire kill all the other ones. Okay, so problem 1. So if my y is x cubed e to the x, what is my y prime? What would you do here? It's the product. Two functions here, they are multiplying each other. It's an f and a g. So now I just realized, what rule do I know that's going to help me with this situation? Right? This one, something that looks like an f and a g. Right? And so what we realize the rule says it's going to be f prime times g plus f times g prime. So of course you're going to have to know that rule in your head. So f prime, I need to differentiate x cubed. How do I differentiate x cubed? 3x squared. How do we know that? Because there's a rule that tells me how to do that. Times g, well g is just the original function, I copy it back. Plus f, which that's the original function, x cubed, copy it back. G prime, derivative of e to the x. E to the x, right? Because it's going to be the derivative of x times e to the x, but we know derivative of x is 1. So that's going to be the answer. I mean, if you want, you could factor this, but I mean, that's fine. I mean, you could actually take out an x squared e to the x and be left over with 3 plus x. Unless there's like a denominator where you're trying to cancel stuff, I don't really care if you take that extra step. That would be fine. Y equals the square root of x e to the x. So again, nothing new here, it's just an excuse for me to make sure you remember how to differentiate the square root. It's going to be the same idea. You plug in, there's two functions f and g, so you realize that, hey, there are two functions multiplying each other. I need the product rule, it's a product of functions. So you are going to have here f prime g plus fg prime. And sometimes students like to go to the side and actually write this down. They'll write down, okay, f equals this, and g equals that, and f prime equals this, and g prime equals that, and then they plug into the formula. That's completely fine. It's up to you. But hopefully you'll know the formula well enough to just kind of on the spot just plug these guys in. What is f prime if you're at right class? One over 2 radical x. So that's going to be that answer. Right? Using the product rule. How are we going to do this one? Product rule again, right? So, two functions multiplying. One function is a 3x squared, the other function is an ln x. So that's like an f and a g. I'm going to find f prime times g plus f times g prime. So the f prime, again, using the power rule and the fact that constants can factor out, so the 3 just sticks around. 2 comes down, multiplies that, that is 6x, times the g, which is ln of x, plus the f, which is the original 3x squared, times g prime. What's the derivative of ln x? It's 1 over x, right? U prime over u, the derivative of x is 1 divided by x. This you can simplify by canceling the x's, so you have 6x ln x plus 3x. And that's fine for me. If you wanted, you could factor out a 3x, but fine on this.
Would you also accept the first one before you cancel the x's?
Usually not. Something like this, I expect you just.
Yeah. Okay.
Because the division is already there. As well as for what we're doing later, being able to simplify the derivative further is going to be useful. So especially when there's an easy simplification sitting there, you're going to want to take the extra step and do it. If for nothing else, for good practice for the future. Okay. What do you want to do here? So you could do the product rule. There's actually a nicer way.
It's one. Well, the derivative of x is one, so you can just find the derivative of x.
Well, no. There's this here, x times radical x. You can actually rewrite that. Notice that this is y equals, well, that's x to the 1 times x to the half, so that's x to the 1.5. So I could actually just use the power rule here. So that one is here as an excuse for a plug here. You always want to try to simplify before applying calculus. And this is kind of something that I would say in general. You do want to apply math in the levels at which you learn it. So you want to get rid of all your algebra stuff before you try to hit it with the calculus stuff. That will help you a lot with problems like this one. So there are going to be times here where it's going to seem like you need the product or the quotient rule at first glance, but you can actually work around it. And in most cases, you should. We will do those cases next time. So actually try to go through the rest of these by tomorrow. And see where you get.